All right, future captains, welcome aboard. If you're wrestling with the ATPL Meteorology exams, then you've come to the right place. We're going to break this all down and help you really master this stuff.
It's that they see the symbols on the chart, but they don't really see what the atmosphere is doing. You know, they're not asking the right questions. Is the air rising? Is it sinking? Is it stable or unstable? Getting that right is literally the difference between a smooth flight and a very, very bad day at the office.
So in this session, we're going to connect that theory to the actual threats. We're talking about taking this stuff out of the textbook and putting it right where it belongs, in your operational thinking as a pilot. Let's get into it.
Okay, so where do we start? Well, everything, and I mean everything in aviation weather kicks off with one simple concept: atmospheric pressure. Think of it as the engine that drives the entire weather machine. All right, now let's look at this, because the vertical movement here is the secret sauce. Forget about wind for a second. In a low, what we call a cyclone, all the air at the surface rushes in, it converges, and it has nowhere to go but up. And that lifting motion, that is the absolute #1 ingredient for nasty weather. Now in a high, or an anticyclone, it's the total opposite. Air sinks from above, spreads out, and everything just calms down.
And here's what that actually means for us in the cockpit. High pressure, that's sinking air, stable conditions, generally smooth flying with great visibility. You know, those perfect, clear, blue sky days. But low pressure, that's rising air. That means instability, clouds, rain, wind, and yeah, a real potential for turbulence. The L on the chart might as well stand for lousy weather, because that's where all the action happens. It matters because that simple up or down movement of air is what decides if the atmosphere is stable or unstable. And trust me, that one thing is the key to predicting just about everything else, especially turbulence.
So let's dig into that. The whole idea of stability is pretty simple, actually. If you take a little bubble of air and give it a push upwards, what does it do? Does it shoot up on its own like a hot air balloon, or does it just sink right back down where it came from?
Okay, don't let this diagram scare you. It looks complicated, but it's absolutely fundamental. If you get this, you get meteorology. It all boils down to comparing two things: how fast the actual atmosphere around us is cooling with height, that's the environmental lapse rate, the ELR, versus how fast our little bubble of rising air is cooling. Now, our bubble cools at one of two rates. If it's dry, it cools quickly, that's the DALR. If it's wet, like inside a cloud, it cools a bit slower, that's the SALR. So here's the magic. Look at the left side where the atmosphere, the ELR, is cooling off super fast. Our rising bubble of air will always be warmer than its surroundings. It's like a cork in water. It's just going to keep rising and fast. That's absolute instability. Now look at the right side. The atmosphere is barely cooling at all. Our rising bubble cools down way faster, gets colder and heavier than the air around it, and plop, it sinks right back down. That is absolute stability. This comparison right here is how you predict whether you're in for a smooth ride or a roller coaster.
And that's the bottom line, right? When the atmosphere is unstable, you get these powerful updrafts and downdrafts. This is what builds those massive towering clouds. This is what causes severe turbulence. And this is what creates thunderstorms and hail. It's basically the atmosphere having a bad day, and you do not want to get caught in the middle of it. Now, the cool thing is, the atmosphere doesn't keep its secrets very well. It leaves us huge visual clues all over the sky. We just have to learn how to read them. And those clues are clouds. They aren't just pretty white fluff, they are giant weather reports telling you exactly what's happening up there.
And really, you can split them into two main families. It's super simple. In stable air, you get these flat, boring, layered clouds called stratiform. Think strata, like layers. But in unstable air, all that vertical energy builds puffy, bubbly, cauliflower-looking clouds called cumuliform. Think accumulate. They build upwards. So the second you see those flat, gray, sheet-like clouds, stratus or nimbostratus, your brain should immediately go, okay, stable air. The threats here are different. We're talking low ceilings, bad visibility, and that annoying persistent drizzle or light rain. The ride itself is usually smooth, but you could be flying on instruments for a long, long time.
But when you see puffy cumulus clouds, especially the ones that are growing taller, your pilot brain should be screaming, unstable. That's a massive red flag for convection and lifting air. Even the little fair weather ones mean bumps, and the bigger they get, well, the bigger the bumps get. It's that simple.
And if there is one thing you write down from this whole session, make it this. For your exams, for your career, for your life, only one cloud, the mighty cumulonimbus, the CB, produces the big three: thunderstorms, hail, and severe icing. It is the undisputed king of bad news clouds, and we stay far, far away from it. No exceptions.
Okay, so let's zoom out. All this stuff we've talked about, lifting, stability, clouds, it all happens on a huge scale where giant air masses crash into each other. These collision zones are called fronts, and they are literally the battlegrounds where our worst weather is born.
And just look at the difference here. A cold front is like a bulldozer. The dense, cold air plows forward and violently shoves the warm air straight up. It's a really steep, aggressive lift. A warm front is much more polite. The warm air can't push the cold air out of the way, so it just gently slides up and over the top. The slope is way shallower, and the lift is much, much slower.
And that totally different kind of lift creates two completely different weather patterns. That cold front bulldozer, it creates a narrow, fast-moving line of thunderstorms, cumuliform clouds, and heavy downpours. It's intense, but it's over relatively quickly. The warm front, on the other hand, with its gentle slope, creates a massive, widespread area of stratiform clouds and steady, light rain that can go on for hundreds of miles. For your exams, remember this. Cold front, intense and narrow, maybe 50 miles wide. Warm front, gentle and wide, maybe 200 miles ahead of the front.
And you know what happens when the fast bulldozer catches up to the slow ramp? You get an occluded front. This is where the cold front literally lifts the entire warm front right off the ground. What you get is a messy combination of both types of weather. When you see an occlusion, you should think mature storm system and complicated weather. Definitely something to plan around.
All right, so let's tie this all together. Here's what you need to remember. Low pressure means lifting air, and lifting air means bad weather. That's the trigger. Instability is the fuel that turns bad weather into really bad weather with turbulence and thunderstorms. Your clouds are the signposts that tell you what's going on. And finally, the type of front, cold or warm, tells you if the weather will be intense and narrow or widespread and steady.
So after all this, what's that one symbol on a weather chart you're never just going to glance over again? Is it those tightly packed isobars, the symbol for a CB, or that sharp blue spiky line of a cold front? Knowing the story behind the symbol, that's what makes a good pilot great and a great pilot safe.
If this helps you connect the dots, do us a favor and hit that subscribe button. We've got a lot more of these ATPL explainers coming your way to help you nail those exams and, more importantly, become a sharp, safe pilot. Until next time, fly safe.